So level 3.1.2 practice test. I'm just going to go over this pretty quickly, and if you guys have any questions, please ask me during class. So, 1. If f of x equals negative 1 half x plus 3, the y-intercept is our b. Just remember, we have y equals mx plus b, where m is the slope, b is the y-intercept. So, our y-intercept is 3. Our slope is negative 1 half. If our slope is positive, it's increasing. If our slope is negative, it's decreasing. If it's 0, it's constant. So our slope is decreasing. And then the graph of this is we start at the y-intercept. So we go 1, 2, 3. And then we go down 1 to the right 2. And then we're just going to draw our line right through there. Remember, slope is always the change in y over the change in x, which is the rise over the run, or the y's over the 1, is how I like to remember it. Okay. 2. The y-intercept is 1. The slope is 4. That's a positive number, so it's increasing. And then we have to graph this line. So I start at my y-intercept, which is 1. Then I go up 4, 1, 2, 3, 4, over 1. So we can see, if we draw a straight line through, that this is an increasing line. Next up, is the dataset linear? If so, state the average rate of change. Average rate of change is the same thing as slope, which is the same thing as change in y over the change in x. Okay, so we look at the change in y. We go up 3. We go up 3. We go up 3. We go up 3. Over here, we go up 2, up 2, up 2, up 2. All of these are additions. So if they're all the same additively, this is linear. And then our average rate of change is 3 over 2. And for 4, same thing. Is the data set linear? So we look, this goes up 3, then we go up 6, then our y's go up 12, and then they go up 24, and our x's are going up 2 each time. So with this case, we notice that our change in y is not the same. So this is not nonlinear because the change in y is not constant. So if it's not constant, then it's not linear. Okay, flip it over, we'll get to the second page. Number 5. When digging in the earth, the temperature rises according to the equation T sub h, or T of h, equals 15 plus 0.01 h, where T is the increase in temperature and h is the depth in meters. What will the temperature be at a depth of 50 meters? All this is saying is find T when h is 50 meters. So plus 0.01 times 50. So I plug that in. This is going to give, I'll just pull out my calculator really quickly. 0.01 times 50 is 1/2. So this equals 15.5 degrees. So second part, based on this equation, at what depth will you see an increase in the temperature of 100 degrees? So I want to know, when this is 100 degrees, what will h be? Sorry, 0.01 h. So then we just solve. So subtract 15 from both sides. So I get 85 equals 0.01 h, which is really 1 out of 100. So then, if I multiply both sides by 100, I get 8,500 meters is our depth. All right, next, use the data below to to draw a scatter plot. So what we want our scatter plot to look like. We want to make sure that we label our axes. So we're going to have time, and then on the x and on the y we're going to have our depth. And now this is where we pull up our graphing calculators. So let's get the glare off. Let's zoom in just a little bit. So I'm going to do a new document. I'm not going to save it. We're going to add our list. This time I'm going to label this as time as my x, and my y is my depth. Now I'm just going to enter the data in. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And then I'm going to enter my y data in. So that's 7, 8, 13, 19, 20, 24, 32, 37, 38, 41, 47. Okay, check that my data is entered incorrectly. So now I'll do Control Doc, add a data and statistics. Make sure I select my time as my x and my depth as my y. So that's what my scatter plot's going to be. If I wanted to plot each one of these, I would say this is 0, and I can do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And if I wanted to do my y's, I could probably do it 5, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so then here's my scatter plot, which I'm going to basically replicate here. So if I go 7, and then 8, and then 6 is 13, and then 8 is 19, and then 10 is 20, and then 12 is 24, and then 14 is 32, and then 16 is 37, then 18 is 38, then 19 or 20 is 41, and 22 is 47. So this is what I mean by show a data table in 2-minute intervals. We label our axes, and this is about what we get. If we drew our linear regression line, it would look something like this. So the question below, it says choose 2 points on our scatter plot. So if I chose, let's say 4, 8, chose this point, and let's say we drew the last point, 22, 47. If we wanted to come up with the equation of the line, we would find the slope first, so it would be 47 minus 8 over 22 minus 4. This is just my point. You can have picked a completely different one. So you get 41 over 18, which is approximately, let's just try that out. 41 divided by 18 is about 2.3. I'm just going to leave it like that. But you can kind of guess to see if your slope is similar. And if we wanted to write the equation, it would be y minus, pick a point. I'm going to choose 8 equals 41 over 18 times x minus 4. Or you could have used the other 2 points. You could have done y minus 22 equals 41 over 18 times x minus 22. Either of these would be the same. And if I ask you, find the linear regression, remember we can just do menu, analyze points, regression, and then linear. And there our calculator will give us our linear regression. Okay, hopefully this helped.